filling out my table, I tend to write, how I'm getting these values. What you put in yours is up to you. If you understand how to get them and you just want to write the final answer, that's okay. I'm going to write radical 1 over 2 equals 1/2, just so it's as I'm explaining it. But if you just want to write the final answer, that's fine. It's up to you. Okay, we talked yesterday. Would it help if I flick off the body?
Yeah.
Maybe I'll still kind of. Okay, we talked yesterday about how to get these using our hand trick. If I wanted to look at my sine of 0 degrees, what would we do? How do we do the hand trick? Hold down your 0, which is your thumb, okay? And then we know sine is the number of fingers above, so square root of that number over 2. So that would be square root of 0 over 2, which is 0. Okay, let's just, while we're here, let's do the rest of them. If I know sine, what other one do I automatically know? Cosecant is the reciprocal. What's the reciprocal of 0? Undefined. Okay, cosine is the square root of the bottom over 2. So that would be radical 4 over 2, which is 1. Tangent, square root of the top over square root of the bottom. Square root of 0 over square root of 4 is 0. You could also remember it's just sine divided by cosine. 0 divided by 1 is 0. Secant is the reciprocal of cosine, so the reciprocal of 1 is 1. Cotangent, reciprocal of tangent, so reciprocal of 0 is undefined. Okay, so we've got all of our zeros. Let's go to 30. Sine of 30. Radical 1 over 2, which is 1/2. Cosine of 30 would be, okay, tangent, you could divide those. You can do, sine divided by cosine. To divide fractions, you have to flip and multiply and simplify from there. Or we could use our hand trick. I told you, tangent is the square root of the top over square root of the bottom. So radical 1 over radical 3 would be 1 over radical 3, which is radical 3 over 3. Because you multiply top and bottom. Cosecant is the reciprocal of sine, so the reciprocal of 1/2 would be 2. Secant is the reciprocal of cosine, so that's 2 over radical 3, which becomes 2 radical 3 over 3. Cotangent is the reciprocal of tangent, so if I flip that, it's radical 3 over radical 1, so radical 3. Have I lost anybody? Let's go to 45. So sine of 45, square root of the top over 2, so it'd be radical 2 over 2. Cosine of 45, square root of the bottom over 2, so radical 2 over 2. Tangent of 45. Radical 2 over radical 2 is 1. Cosecant, reciprocal of sine. So if I take radical 2 over 2 and flip it, you get the radical off the bottom, so it's 2 radical 2 over 2. That just turns into radical 2. Secant, reciprocal of cosine, will give us the same thing. Cotangent, reciprocal of 1 is 1. So if you fold in your 60. Sine is the top, so that would be radical 3 over 2. Cosine is the bottom, so radical 1 over 2, which is a half. Tangent, radical top over radical bottom, so radical 3 over radical 1 is radical 3. Cosecant, reciprocal of sine, so 2 over radical 3 becomes 2 radical 3 over 3. Secant, reciprocal of cosine, reciprocal of 1/2 is 2. Tangent, reciprocal of tangent, so 1 over radical 3 is radical 3 over 3. And 90. So sine would be radical 4 over 2, so 2 over 2, which is 1. Cosine, there are no fingers below, so radical 0 over 2 is 0. Tangent, sine over cosine, or radical 4 over radical 0, undefined. Cosecant, reciprocal of sine, so the reciprocal of 1 is 1. Secant, reciprocal of 0 is undefined. And cotangent, what is the reciprocal of undefined? 0. Okay, so it looks like a lot of stuff there, but really it's that hand trick. Now, if you don't get the hand trick, there are other patterns here. You could think, okay, sine is just square root over 2. And it's 0, 1, 2, 3, 4. And simplify. And we know sine and cosine are reciprocals, or sorry, are cofunctions. So once you have sine, cosine is just that row in reverse. Secant and cosecant, they are the reciprocals of sine and cosine. So if you have sine, you can get cosecant by doing your reciprocals. And these are cofunctions, so secant is just the cosecant in reverse. It is. Tangent is sine over cosine. So if you have these, you could divide. 0 over 1 is 0. 1/2 over radical 3 over 2. I worked out on the board, radical 3 over 3. Radical 2 over radical 2 over 2 divided by radical 2 over 2. If you divide something by itself, you get 1. So if you work through and divide those things, you get tangent. And cotangent, you can either do with the reciprocal or it's tangent backwards because they're cofunctions. So really, if you have sine, you can get this entire table. Because once you get sine, cosine is just the reverse. Tangent, you divide them, and you have all your cofunctions. There's a lot of patterns here. There are other patterns, but I don't want to confuse you too much with doing the same thing. That's enough? Yes, ma'am.
So like on the quizzes, do we have to show anything?
No. I will tell you right now, this will be the first page on your test when we take this Chapter 2 test. I know we're only in the first and second sections, but when it comes to that point, this table isn't going away, so I will be giving it to you on the test. Okay. All right, so you guys understand how we got all that? Okay. I want to go ahead and start the next section. So now we are really good at finding our trig functions for the 0 through 9. We can now do this, use that information to find our values for other angles. I think we can all agree we don't want to have to memorize any more values, right? So we have everything. We just have to learn how to use it now. Okay, in this piece, in order to take the knowledge that we have and extend it to other functions, we are going to be talking about what are called reference angles. When I talk about a reference angle, it's theta with a tick mark. That's called theta prime. You might also sometimes see different books use theta with a hat on it. So theta prime, theta hat, they both mean a reference angle. It is a positive angle between the terminal side and the x-axis. That is very important. The reference angle is the distance to the x-axis every time. Let's just jump right in. I think it'll make more sense if I just do it in examples. So we're going to give the reference angle for each of these. First one, if I'm talking about 30 degrees, okay, the reference angle is just distance from that angle to the x-axis. So if I were to draw this, we know all of these are angles in standard position. 30 degrees is still between 0 and 90. So what is the distance to the x-axis there? Still 30, isn't it? If you have something in the first quadrant, if you already have an acute angle, something between 0 and 90, that is your reference angle. It's not going to change. You could write theta prime equals 30 if you want. The reference angle and the angle are the same there. If I gave you 135 degrees, so 135, here's 90, 180, so 135 will be in between for standard position. The reference angle is the distance to the x-axis. So when I'm looking for my reference angle, I am looking for this down here. How would I find that? $180 minus the 135, and that gives me 45 degrees. Your reference angle itself will be something between 0 and 90 every time. Yes? Okay. If I said 240 degrees, what quadrant is that in? Quadrant 3, because it's between 180 and 270. Okay, that represents 240. My reference angle is the distance to the x-axis every time. So I am looking for this piece right here. How would I find that? And we get a reference angle of 60 degrees.
Why would you go to that side?
Because a reference angle is defined to be distance to the x-axis. So if you went the other way, that would give you the distance to the y.
What if you went like all the way to the X?
You went then that like all the way back here?
No, like the other way. Like over there.
Like to the 360 line.
Oh, the reference angle has to be acute. So if you went all the way to the 360, that would be bigger than 90. Other questions? What's the question? Okay, 330. What quadrant is that in? Quadrant 4. So this represents 330. Okay, I need distance to the x-axis. We want the closest possible distance. So that will be this piece right here. How would I find that angle? You do 360 minus 330. And we get 30 degrees. let's talk about some negative angles. If I give you negative 210, you have two options. You can either deal with the negative, realizing that that just means you're spinning the opposite direction, or most people prefer add 360 and get a positive angle. Is that what you guys want to do?
Yeah.
Alright, so if I just add my 360 and get the coterminal angle, that gives me 150. So 150 is between 90 and 180. How would I get my reference angle?
180 minus 1.
We'll get 30 degrees. Okay, if I had negative 140, do the same thing, add your 360, and that would give you 220. So if you think about that, that's between 180 and 270. So how do I find my reference angle? -220, which gives us 40 degrees.
Could you take the absolute value of that number and then subtract it from the nearest? Or would it not work every time?
It will not work every time.
'Cause like that
Well,
one,
let's see. It would
I'll
put
take
you
the difference of the
in.
two.
It would be okay because it'll put you in there. That would work. Okay. So far, so good? They don't have to be nice, pretty angles. I could give you something in degrees and minutes. So I just wanted to make sure you could handle that if I gave you one a little bit uglier. If I said 195 degrees, 10 minutes, what quadrant would that fall in? Quadrant 3. It's a little bit bigger than 180. So then how would you find it? Subtract 180 from that. It's like 180 degrees in 0 minutes. So we just get to do 10 minus 0 and 195 minus 180. You guys do B for me. Draw it and give the reference angle. Your angle would look like this. So how do I find the reference angle? 180 minus that. So this time we have to borrow. So we get 48 degrees, 40 minutes for the reference angle. All right, so is everybody good with finding the reference angle? It seems easy, yet somebody always tries to subtract 90 or the 270 to find it. You're only using the x-axis, so you're only using the 360 and the 180. So if we wanted to generalize this, we could kind of summarize what we do based on the quadrant. This notation just means theta is in quadrant 1. So if our angle is in quadrant 1, the reference angle is equal to the angle. If it's already an acute angle, the reference angle is no different. If it was in quadrant 2, how did we find the reference angle? Like 180 minus the angle. So the reference angle is 180 minus theta. In quadrant 3, what do you do? I gave you like 225, what would you do? Right, your angle minus 180. And if you are in quadrant 4, what do? I said like 300 degrees. 360 minus your angle. Now for me, it's easier just to think about the problem rather than trying to memorize these rules. Some people really like rules written out, so that's why I put it up here, but really you can just think through it. Notice we never use the 90 and the 270. It is only the x-axis. So now, we are going to be able to use our reference angles to help us find our trig functions of non-acute angles. In other words, now I'll be able to find the sine of 120 degrees without memorizing anything new. If you think about an angle and its reference angle. Okay, for instance, if I said, let's just use the 120. You don't even necessarily have to write this down unless you want to. I'm just kind of explaining for a moment. This is 120 degrees, which means my reference angle over here is what? 60. If I wanted to find my trig functions of this 60-degree angle, those would be the same as a 60-degree angle over here, except it could be positive or negative. You'll have to decide based on your quadrant whether you're positive or negative. You know, thinking in terms of x, y, and r, your x's are negative in the second quadrant. Y and r are still positive. So, what we're going to do on these problems, if our angle is not already between 0 and 90, we will name what quadrant we're in, we will find our reference angle, and then we will evaluate it based on those two pieces of information. So on every single problem, from now until you walk out of my room after you've taken your final, if I give you one of these, I'm going to say, what's the quadrant, what's the reference angle? Every single time, and I expect you to write that down. Now we're just going to start evaluating these things. So I want to find the sine of 240 degrees. So, two pieces of information. I want quadrant. What quadrant is 240 in? 3, because it's between 180 and 270. Then I want your reference angle. How would I find that? Distance to the x-axis. 240 minus 180. If you need to draw a picture, you're welcome to do so. And that is 60 degrees. Okay. So now, here's the two things that we're going to do. Talking about 60 degrees. What is the sine of 60 degrees? Radical 3 over 2. In quadrant 3, tangent is positive, so sine is negative. And my answer is negative radical 3 over 2. That's it. Let's practice some more. So 315. What quadrant is 315 degrees in? Reference angle. In quadrant 4 we do 360 minus 315 and we get 45. Okay. 45. Tangent would be radical 2 over radical 2, so 1. In quadrant 4, all students take calculus. Cosine is positive, so tangent is negative. So negative 1 is my answer.
angles always be?
Yes. We'll learn in the next section. If they're not one of those angles, we're going to do them on the calculator and just use a decimal. Okay. Let's do cosecant of 300. So what quadrant is 300 in? Quadrant 4. Reference angle, so 360 minus 300 is 60. Okay, if I'm doing cosecant, if I want to use my hand trig, what trig function am I going to think about? Sine. So what is the sine of 60? So we have to flip that. So cosecant would be 2 over radical 3, which is 2 radical 3 over 3. Now you have to decide positive or negative, which is based on your quadrant. In quadrant 4, sine is negative, which means its reciprocal is negative. So far, so good. Let's do a few more. I'm probably not going to do both of these. Let's just do one of them. Let's find all 6 trig functions for 585 degrees. What did you do with 585? Subtract 360 first. So that gives me 225. What quadrant is 225 in?
3.
Okay, reference angle. In quadrant 3, you subtract 180, which would give us 45. Okay, so we are finding all 6 trig functions. Okay, first tell me, in quadrant 3, which ones are positive? Tangent is positive, so cotangent is positive. That means these other 4 are negatives. Okay, so 45, hold in your 45. Sine is radical 2 over 2. Cosine is radical 2 over 2. Tangent is 1. Then we just do reciprocals. Reciprocal of radical 2 over 2 is just radical 2. And reciprocal of 1 is 1. Any questions on this?